All right, so I've been dancing around this a little bit, so let's get into it here. As far as attic ventilation, we are required by the code to vent the attic at a ratio of 1 square foot of ventilation per 150 square feet of attic space. Okay? And we've already talked a little bit about this in our cornices lecture, but the best way to vent an attic is with intakes at the soffit and exhaust at the ridge. Okay, so we have a buildup of hot, humid air in the attic. Okay, we're going to draw in outside air through the soffit, through the freeze blocks, and it's going to push that hot, wet air out of the ridge vent. Okay. The other thing that we want to do, like let's say we've got a really cold climate and it's snowing on a roof. Okay. It's snowing everywhere, but snow's accumulating on the roof. We want that snow to stay on the roof, okay, because that's additional insulation for this attic. Okay, the snow is acting as insulation. So we want to draw in cold air and keep the bottom of that sheathing cool. Okay, so that's another. And so what can happen if you don't do that is that snow can melt. If this is warm, the sheathing's staying warm, the snow will melt. It'll run down to this eave where it's no longer accessing this warm attic, and it'll refreeze, and you can have this phenomenon called ice dams, where the water refreezes and expands because it's turning into ice, and it can push in through the soffit and underneath the shingles, and you can have moisture problems right here. Okay, so we're getting a little off track, so let me bring it back here. But when we have this kind of traditional vented roof, it's called a cold roof. Okay, very effective, very easy to do. Okay, and here's this picture I promised you of the baffles. Okay, this is like a piece of, it looks like they used a piece of drywall or something like that and attached it to the underside of the trusses so that the air is moving over that baffle. We can insulate all the way up to this baffle. Okay, and then this is actually a good picture. You know, when we're talking about trusses, we talked about our raised heel truss and how we have a stand for that truss so that we can get better insulation up here. See, right here, they've had to cut this insulation back to match the slope of the roof. Okay, this is probably R30 or something like that, but this is having to get cut back. So there's actually less insulation in this corner. When you use that raised heel, you can get more insulation into that corner. Okay, anyway, this is a cold roof. Okay, the thermal barrier is at the ceiling. Okay, if we've drawn a line where the thermal barrier is going to go on the house, drawn it along the floor, up the walls, over the ceiling, and we've made a loop. Okay, here's another picture of some baffles right here, stapled up against the roof deck. This is providing a ventilation chute up this roof. Okay, keeping the sheathing cold and dry. Okay, we can really, like I've said, hot rod that ventilation system with a range screen. The more air that we're pumping through this thing, the better. Okay? The more air that's moving, we're going to move any moisture laden air out, and we're going to avoid problems with condensation. Okay? What tends to happen, what tends to be the drawback with these cold roofs is that the temperature of our attic is usually the opposite of what we have it in the house. Okay, in the wintertime, the attic's freezing, okay, because we're introducing outside air into it, and it's really cold in the attic. We're trying to keep our house warm. Depending on what kind of insulation we've got going on that ceiling, depending on how good of a job we've done with the air sealing, that can depend a lot on how much thermal transfer is happening between the house and the attic. Okay. Same thing, if it's really hot in the summertime, the attic's going to be 140 degrees, okay? And we're trying to keep the house 70 degrees or something like that. There can be potential for some thermal transfer from the attic to the conditioned space, okay? And then that problem is kind of exacerbated if we've put all the ductwork up in the attic, okay? And this is a really common thing to do. It's been the practice for 40 years now, is put everything in the attic. There's nothing else up there. It's out of the way. It's easy to run all of our ductwork around, okay? But this is a problem, okay? Let's say it's 140 degrees up there in the summertime, and we're trying to run our air conditioning through that space. Okay, we're trying to run 50-degree air through a space that's 125 degrees, and it's going to get heated up. Okay, even these insulated ducts, these are only insulated to like R6 or something like that. So we're going to be fighting nature by doing it this way. Okay. Conversely, it's really cold in the attic. We're trying to run the heater for the house. We're trying to run hot air through a cold space. Okay, it doesn't make a whole lot of sense. And then the best thing to do is to just take the ducts out of the conditioned space, or put them, in a conditioned space and get them out of the attic. Okay. Now, an alternative to this is to have what we call a hot roof. Okay, we're not venting the attic. Okay, it's completely unvented. It's conditioned, and it's totally insulated. Okay, we've moved that thermal barrier up to the roof line. Okay, now this makes sense. Okay, if we want to have stuff up here, if we want to have our ductwork up here, we kind of have to condition this attic and create a hot roof assembly. Okay, for reasons I've talked about previously, though, this is potentially problematic. Okay, when we have to create an air and vapor barrier here, that is kind of a risky assembly. Okay, the easiest way to do this is to just foam everything. All right, you can see they've come in and they just foamed all of these rafter bays. It's easy to do, okay, but it is risky, okay, for this reason. Okay, if we've taken away the capacity for the attic to vent, any moisture, any air that does get in there is going to get trapped right here, and it's not going to have a way out. Okay, but just back to one of the good reasons potentially for this, if we condition this space, if we fully insulate it and move that thermal barrier up into the roof, then we can have the ductwork up here. Okay, I am of the school of thought that says, let's just take the ductwork out of the attic. Okay, put the ductwork in the conditioned space so that the air that's moving through that ductwork is the similar temperature to what's in the house. Okay, we're not fighting it as much by having it in a really hot attic or a really cold attic. Okay, we can save a lot of energy that way. It's a lot easier on the equipment also. Okay, the forced air unit, the air conditioner is not going to be fighting it constantly. Okay, so to wrap it up, heat transfer is going to occur. We can't stop it. All we can do is slow it down, okay? Depending on the type of insulation we have, the thickness of the insulation we have. Remember those three methods of heat transfer. We've got conduction, heat moving through solid materials, convection, heat moving through liquids and gases, and radiation, heat moving through visible and non-visible light, okay? All of these materials have their benefits, okay? You can do a really effective job with any insulating material. You can do a good job and get a good R value out of it and have a comfortable house, okay? Some materials are going to be better than others depending on your situation, okay? Depending on what kind of house you build, depending on what kind of choices you want to make with the materials that you buy, okay? But a lot of it comes down to the installation. And then I would say that's one of the things that's really appealing with spray foam. And there's this like saying, it's foam it and forget it. Okay, somebody comes in and spray foams everything and it just expands into all the cavities, and you don't really have to pay a lot of attention to the details, okay? But I'm going to make one more pitch to get you away from spray foam. It's really, really expensive, okay? And not only like monetarily, but I would say the environmental cost is really high. And fiberglass insulation is dirt cheap, and you can achieve the same results depending on what kind of job you do, okay? How you want to pay attention to details. So I hope this has been good for everybody. Please email me if you have any questions, and I wish you the best. Thank you.